In April 1937, Air Commodore Sir Frank Whittle's first gas turbine aero engine was given its initial trials. This engine was designed and built with the assistance of the BTH Company. The firm of Power Jets Limited had been formed to proceed with its development. After working under Whittle's direction at a small factory near Rugby, the firm moved in 1943 to a new factory near Leicester, built for them by the government. Here, rapid progress was made in the development and manufacture of Whittle engines. This is a model of the W2 700 engine, which, although weighing only slightly more than the original flight engine, developed 3 times the power. The way in which the Whittle jet engine works is simple. Air is drawn into the engine by a centrifugal compressor. Although similar to the compressor of an ordinary aero engine supercharger, it is much larger, handling more than 10 times the amount of air. After being compressed, the air passes to the combustion chambers, where it is heated by a spray of burning paraffin or petrol. The heated air and products of combustion then pass straight to the turbine, which is driven round at speeds up to nearly 20,000 revolutions per minute. The turbine in turn drives the compressor, to which it is directly coupled. A large part of the energy in the heated air is absorbed by the turbine, to enable it to drive the compressor and fuel pump. The remaining energy is used directly in the jet to drive the plane forward. In May 1941, the first flight of a British jet-propelled aeroplane took place. Built by the Gloster Aircraft Company and powered by a Whittle engine, the E-28 was purely an experimental plane. With this plane, much useful flying experience was obtained. The absence of noise and vibration in the cockpit, coupled with the simplicity of the controls, greatly impressed the pilots. E-28 can now be seen in the Science Museum, South Kensington. Here is the prototype of the RAF's first jet fighter, the Gloster Meteor. The early Meteors were powered by Rolls-Royce Welland engines. These were a development of the Whittle W2B engine. The first RAF squadron to be equipped with Meteors was number 616. After carrying out their initial training at Farnborough, they transferred to Manston Aerodrome, Kent, in the summer of 1944. While at Manston, they went into action against the flying bombs, and were found to be the most successful of our fighters, shooting down the greatest number of bombs per flying hour. Four years later, the first British Aircraft Constructors' Show to be held at Farnborough took place in September 1948. Although piston engines were still in evidence, jets were very much to the fore. Next to the standard Meteor stood the first Meteor trainer, recently returned from a successful tour of Europe. In it, Gloucester's chief test pilot, Bill Waterton, had given several continental countries their first experience of a jet plane's speed and grace. Close by stood the de Havilland Ghost-engine Vampire, the first jet plane to hold the world's altitude record. The first single-engine jet fighter specially designed for the Navy. Powered by a Neen, its short twin jet pipes allow extra space for fuel tanks and thus give it increased range. The first jet-driven all-wing aircraft, the AW-52. The first four-jet airliner, the Neen-engine Tudor 8, 2 days after making its maiden flight. And the world's first jet airliner, the experimental Neen Viking. And here comes the first jet flying boat, piloted by Geoffrey Tyson. The Saunders Row naval fighter doesn't seem to mind which way up it flies. Its two Metropolitan Vickers axial flow turbines give it great speed and maneuverability. Next, the Meteor Mark IV takes off. Here comes the Vampire. Some expert aerobatics by John Derry. Next, the Hawker naval fighter. The Meteor trainer. The AW-52. And so, to the future. Jet-propelled airliners will fly fast and at great heights. The world will grow smaller.
We were running into all sorts of difficulties in 37 and 38, not the least of which was the financial problems. because our financial backers were expecting miracles, I suppose. They thought we would have an aero engine within a matter of weeks. Well, of course, we had breakdown after breakdown, and they began to lose heart. And they did not produce the money that they promised. They had an option, you see, to produce a certain amount of money after a certain amount of time, and they obviously got cold feet. The result of that was that the control of the company passed into the hands of Williams, Tilling and myself. It didn't give us any money, but one of the conditions that we made for Falcon Partners to stay in the job was that they found a certain amount of money, and they did, in fact, put in another £3,000. And we were further helped by the fact that the BTH accepted 2,400 shares instead of £2,400 for a reconstruction of the engine. When we were in financial difficulty, the Air Ministry were very hesitant to help because we were in financial difficulty. There was a catch-22 situation going on. They said, this is a company backed by the city, Falcon Partners being a city company, who are just out to make money quick. And here they are running out of money. They don't have the courage to put money in. We're not going to risk our money. And so, as I say, you had a catch-22 situation. But they did, after we'd first run the engine and shown that it at least was self-driving, they did agree to a very limited contract, £200 an hour for running of the second edition for 10 hours. That would have been 10,000, 2,000 who had managed to complete it, £1,000 for a report on what had happened up to then, and so forth. A contract which totalled about £5,000. But there was another catch-22 situation came out of that, because as soon as they gave us a contract, we came under the Official Secrets Act and couldn't raise private money. Because you can't go to people and say, look, we've got a wonderful idea, put some money into it, we can't tell you what it is. So the acceptance of a contract from the ministry virtually stopped us from raising private money.
However, you had in, I think, Sir Henry Tizard, and I think also in Arthur Tedder, some fairly staunch friends during 37, 38, 39.
One of the big factors in our in the course of the development was that we enlisted the interest of Air Marshal Tedder and Sir Henry Tizard. Sir Henry at that time was chairman of the Aeronautical Research Council, and he, you might say, was a believer in gas turbines, and fortunately too he seemed to be a believer in me. He seemed to think that I knew what I was doing, and I think in the light of event he was possibly right. And Tedder came up to see what we were doing and saw the engine run and was suitably impressed. And he became a convert and decided to back the project.
But at that time, the Director of Scientific Research and the DDSR from the Air Ministry, what was their attitude?
The Director of Scientific Research had been converted about a little earlier than Tedder and Tizard, because he was more intimately connected with it. But he'd been a sceptic, you know, up to about June 1939. He'd been giving us the money, what little he did give us, on the basis that it was long-term research. And he thought it would contribute to what was going on at Farnborough.
And, of course, at that point, was it 1937, 38? Can you just give me this back? At that time, you had from Farnborough, in the person of A.A. Griffith, a rather unsatisfactory report.
When, just after the engine first ran and we'd submitted a report to the Air Ministry, this was the subject of another report by Griffith, the man who turned the job down in the early days, and his report damned it with faint praise. He brought in all the difficulties, said that no propeller meant that we wouldn't have the slipstream to help us take off, and so forth. And his final conclusion was more or less that it might have some use if high performance were needed for a very short time. I don't know why Griffith reached that conclusion. except that he seemed to ignore what we were trying to do. He talked as though the whole idea was to fly just where the Spitfire and other aeroplanes were flying, namely at heights up to, say, 20,000 feet and so forth. He didn't seem to register that we were aiming to fly at 40,000, 50,000 feet, well, even 60,000 feet.
Fine, I come now to Dr. David Pye, and June the 30th, I think, 1939, wasn't it? Can you tell me what happened on that day, the 30th of June?
On June the 30th of 1939, we managed to get a big breakthrough in the attitude of the Air Ministry, in that Pye, Director of Scientific Research, came up to see the engine run, and we managed to keep it going for about 20 minutes in his presence at 16,500 RPM, at which speed it pulled about 860 pounds of thrust, and he became a complete convert. So much so that he agreed that an engine for flight should be ordered, and that an aeroplane to use it should be ordered too.
Perhaps you could give me that little anecdote about driving him back to the station.
An odd thing was that he became such a convert that when I drove him back to the station to get his train back to London, I had the curious experience of hearing him explain to me all the advantages of the engine, that it could run on any fuel, that it was vibrationless, etc., etc. When the ministry decided we got a good project, they wanted to give an order for an aeroplane and for the engine. Well, they gave us the job of getting on with the engine, and we subcontracted the building of it to the BTH. We wanted them to give us the order for the aeroplane too, so that we could subcontract and thereby control it. But they wouldn't have that. They gave the contract direct to Gloster's. Well, that was fine, as it proved, because Gloster's, under Carter, proved to be very efficient. So the arrangement was satisfactory in the end. And we designed the W.1 engine for flight, very similar to the original engine called the W.U, but very much lighter. It was designed to produce a 1,240 pounds thrust, and the weight came out at about 620 pounds. The consequence of having to allow both for the difference in speed between the root and the tip of the blade, and for the difference in speed of the whirling air entering the blades, it meant doubling the twists of the blades. Another consequence of this way of designing was that it made a tremendous difference to the end load on the bearing. In fact, the end load of 1,800 pounds they'd been talking about virtually vanished.
Simplicity, I think, was the keynote of the first engine, wasn't it? The simple centrifugal compressor. Perhaps you could explain that.
We aimed to have the simplest possible engine to start with. There were certain alternatives open to us, the centrifugal compressor or the axial flow compressor. The centrifugal compressor is a very simple thing. It's simply a kind of glorified rotor, the kind that you have, say, in a vacuum cleaner, and with the diffuser blades on the outside. So there's just that single set of blades for the compressor, instead of the axial flow, which has many, many rows of blades, each of them having, say, 50 blades. So it's a much more complicated device. I sat on the fence and I took out my first patent because I had a two-stage axial flow with the centrifugal stage as a third stage. But when I came down to designing the engine, it had to be simple. So I selected the single-stage compressor, centrifugal type, with a single-stage turbine on the same shaft.
But the airflow was curved, in fact, wasn't it?
Well, not originally. Well, there were three sets, really. You might say the first was curved in that we used a single sausage-shaped combustion chamber. Then we went to a rather complicated one, which I won't attempt to explain now. And from that we went to what came to be known as the reverse flow kind. The reason for that being that we wanted to be able to use the same rotor assembly, that's compressor and turbine, that we had all along. And we could only do that by using reverse flow combustion.
You didn't go along with A.A. Griffiths altogether in the aerodynamic blades design. How were your blades designed?
Griffiths had a theory that you should design the blades as aerofoils. But I did not agree with that then, and I do not agree with it now. He argued that you should design the blades. I say that you should design the channels between the blades.
Which meant what?
And the difference being that, since you are steering fluid through channels, clearly it's the channels that are important. If you make an aerofoil and then bend it to give the right kind of angles you need in a turbine, then you get constriction and divergence which you don't want in a channel.
Fine. This may be the point, in fact, I'd like to go over it again in this context. Can you tell me something now about the vortex blading theory and how it came to be an issue?
I found out by more or less by chance that the turbine blades being designed by the BTH were based on a quite different concept of blade design than what I thought was proper. And I didn't realise this until I'd left the blade design to them until I went to a meeting in the Deputy Chief Engineer's office, and where they were discussing a change in the blade design. And they were saying that one of the consequences of that change would be a change in the end thrust on the rotor. The load on the bearing, thrust bearing, would be 1,800 pounds instead of 150 or whatever it was. And I couldn't understand this. So I went away and thought about it. And I went out to the blade design office and asked one of the engineers there, L.J. Cheshire, I said, what do you assume to be the pressure difference between the root of the blades and the tip of the blades after the fluid leaves the nozzles? And he said, what pressure difference? So to my astonishment, I found they did not assume that the air coming out of the nozzles was whirling, but that each pair of nozzles was sending out straight jets, which of course is not what happens.
And if the effect of this was that you altered the blade, is it pitch or?
This particular, I pointed out that the fluid coming out of the nozzle ring would be a vortex, and the centrifugal pressure gradient meant there would be a corresponding difference in velocity. See, at the root, at the inside smaller diameter of a vortex, fluid is moving much faster than it is at the tips. You see that in water running out of a bathtub. And as the water moves nearer and nearer to the centre of the vortex, it spins faster and faster. Well, that's what happens in the flow out of a set of turbine nozzle rings. And to allow for that, it means you have to put a good deal of extra twist on the blades. In fact, double the twist that the BTH were putting on.
And that settled the problem. Right, I come now to Power Jets itself, the company in 1939. How many employees did you have, and how many of them were fully trained engineers?
In 1939, we only had just a handful of about half a dozen. And then beginning of 1940, we began to build up a team, and I was very careful in picking real quality. You know, first-class honours Cambridge, first-class honours Oxford, Imperial College of Science, and so forth, Whittle Scholars. Well, I had quite a collection, and I think I can claim to have built up a brilliant team.
A young team?
A young team, yes, mainly. There were just, one was a little bit older than myself then, and then we added to that one of my former instructors. He became my deputy. He was quite a bit older than me. That was Wing Commander Lees.
And presumably for the young engineers, how were they recruited in terms of secrecy?
When we were recruiting young engineers, they came to this scruffy old foundry that we were now inhabiting, and were somewhat surprised, I think, when our managing director, as he had become, L.L. White, they went in this old ancient brick building up to rickety wooden stairs into an office with a beautiful carpet.
Farnborough had started, and indeed was the first research establishment in the world, to start work on compressibility and transonic testing. and it started using the Spitfire 5 back in 1941.
Its boffins realised they had the key to supersonic flight.
So they issued a specification in 1943 for a supersonic research aircraft. And they chose a Miles aircraft to design, with the help of Farnborough, the actual aircraft.
This was designated the Miles M.52.
One has to say they made a very good job of it. It had a special engine to be built by Frank Whittle, which was turbofan with reheat. We believed we could reach 1,000 miles an hour. And the aircraft had also a biconvex wing, which was known as the Gillette wing. And thirdly, it had a flying tail.
This folds the tailplane and its elevator into one solid piece, which makes the aircraft more controllable as it nears supersonic speed.
I think because of the impression that I made, or so I'm told, with getting the Mozzie on the deck, they thought, we'll use this guy in the high-speed flight.
In 1944, Brown became the Navy's first pilot to fly a jet aeroplane. By contrast, no test pilot at Miles had yet flown one.
I was chosen to be the pilot on it for the simple reason that the fuselage at the pilot position was only 4 feet in diameter, and you couldn't get a pilot in there of more than 5 feet 8. In December 1945, when the aircraft was 92% ready for first flight, there arose a great problem that Frank Whittle, who was then running Power Jets, fell out with the establishment over the question of whether he or Rolls-Royce should produce production jet engines. It was ruled that Rolls-Royce should do it. He was so unhappy with this that he resigned from Power Jets. A month and a half later, the M.52 was cancelled. I had already been given the date for the first flight, which was to be October 1946 at Boscombe Down. There was no prior notification given either to Miles or to Farnborough. And I was hopping mad, frankly, when I heard the decision.
Nobody would tell Brown why the M.52 had been cancelled.
About 6 months before the cancellation, the Ministry of Aircraft Production had ordered that we receive a visit from the Americans, that everything be shown to them, nothing to be withheld from them whatsoever. They would even be given copies of all the reports and copies of the design work, etc. Without this visit, the Americans would not have advanced through the Sun Valley with the X-1 as early as they did. I think it was certainly well within our grasp and taken away, and this is the galling thing, for a reason that up to today we are not sure why it was done.
Have you thought how your own life would have gone down a different avenue, perhaps?
Perhaps, yes. I wouldn't have relished it to the same degree, I don't think.
While waiting to fly the M.52, Brown had been working at Farnborough on another project that would further expand the military potential of jet aeroplanes.
We were advertising, but of course we couldn't say what we were advertising for. And when we were interviewing them, we couldn't tell them what we wanted them for, although I think some of them guessed from the questions we asked.
Can you give me some idea of the costs, the Power Jet's total costs to 1939 compared with Germany?
Right from the start, we were working on a shoestring financially. £2,000 was the original sum subscribed, but dribs and drabs of money came in, £200 a friend of mine, £500 from a friend of someone else, and it built up slowly. And By 1939, we had spent, I don't know the actual figure, but I think it was about £7,000. In the balance sheet for July of 1939, the item to cost of unit was 4,000 and a few £100. So though we'd been going for over 2 years, we had, that's all we'd spent on the engine. We were doing monthly bill, BTS were doing it on a cost-plus basis, but fortunately for us, their overheads were only 150%.
The fact of the matter is, of course, that you were having to rebuild the engine out of old parts, and I think the official historian says that this really hampered progress quite considerably.
We were hampered repeatedly, not only by money difficulties, but by they're associated with money difficulties. We couldn't afford to replace parts which had been damaged.
Overall, at this time, were you aware that Whitehall itself was troubled by what it felt to be the anomalous position of power jets?
I don't know what the position was of the ministry with all the various undertakings they were trying to give to various people. They were telling power jets they would protect us. They were trying to get undertakings from the Rover Company, which the Rover Company refused to give. They were trying to get undertakings from the BTH Company, which they were refusing to give. So they were in a first-class difficulty, really.
And it was this, presumably, that prompted their move towards Rolls-Royce, was it?
The situation became so bad that it looked as though there would be a complete hash of everything. The Rover were making such a poor job of the engine that the order for the production of the Meteor was cut right back. And then Sir Wilfrid Freeman at the ministry wanted to hand the whole job over to Rolls-Royce. I successfully resisted that. I think I did anyway. But nevertheless, Rolls-Royce did come into the picture in a big way, in that it was agreed that they would take over the job from the Rover Company and hand over to the Rover Company their tank engine, diesel engines they were making. And from the moment that Rolls-Royce took over, the picture changed completely.
How was the picture then at Clitheroe at Barn Oldswick at that time? Did you know?
At the end of 1942, Rovers were just staggering along, getting 30 hours running out of, say, 6 engines. And as soon as my feeling is that they didn't want it to work because they wanted their B-26 to supersede the W2B. Anyway, when Rolls-Royce took over, within 1 month, the running time jumped more than tenfold to over 400 hours.
And one of the main agents, at any rate, one of them behind this was Sir Stanley Hooker. What was your relationship with him, or Dr. Hooker, as he's then called?
The leading people in the Rolls-Royce team, which brought about this revolution, you might call it, was headed by Stanley Hooker. Dr. Hooker, as he then was, and Stanley Hooker as he became later. He was a great leader. In 3 months, he and the team he had at Barn Oldswick had the engine up to its full design performance, and in fact, shortly after, they improved on it. And the main reason they did that was they made a modification to the turbine, which I'd recommended 2 years earlier. That was just altering the angle of the turbine blades through 5 degrees, and that put the engine right, and it was able to go through its type test at full design performance.
In 1923, Frank Whittle joined the Royal Air Force. The 20s and early 30s were the formative years of the RAF. It was small, select, highly trained. RAF aircraft followed the fashions of the day, no longer constructed of wood, it is true, but still fabric-covered, wire-braced biplanes, differing little in essentials from the machines that had fought over the trenches in the closing stages of the Great War. On joining the RAF as an aircraft apprentice, Frank Whittle was trained as an airframe rigger, a trade he was never in fact to practice, for on completion of the 3 years course, he was selected to a much-coveted cadetship at the then newly created RAF College at Cranwell, where he learned to fly and was duly commissioned as a pilot.
So I first went solo on the Avro 504K, and then on the Avro Lynx, then from there to the Bristol Fighter, then the DH-9A, and then on to the Siskin in my last term.
To be an RAF pilot was in those days a most agreeable position for a young man, flying from neat grass airfields all graced with well-appointed messes, a chain of exclusive flying clubs stretching from Britain across the empire. The biplanes of the 30s, like these Hawker Harts, could achieve sea-level speeds of around 180 miles an hour. The fastest single-seater of the time only managed just over 200. But as they climbed into the thinner air, their performance dropped drastically, a characteristic of the piston-engine propeller combination. Frank Whittle, while a cadet at Cranwell, had written a paper, Future Trends of Aircraft Design, in which he had predicted speeds of up to 500 miles an hour. This would be impossible to achieve with biplanes due to the drag inherent in their design. For however powerful their engines, the maximum speed of a practical biplane would be limited to around 250 miles per hour. The 1929 Supermarine S-6 Schneider Trophy seaplanes were to prove the point. That year, their 2,300 horsepower Rolls-Royce R engines had enabled them to win the trophy at 340 miles an hour. Later, in 1931, with still more power, one of them became the world's first aircraft to exceed 400 miles an hour in level flight. Yet in a sense, the Supermarine S-6s were a red herring. Their very success obscured the fact that their performance was very nearly the practical limit obtainable, a fact that Cadet Whittle had realized at Cranwell.
One of the things that I did was work out what I now know was the well-known Breguet equation, which indicated that if you wanted to fly both fast and far, you'd had to fly at such a height that it was quite beyond the, and at such a speed, that it was quite beyond the piston engine and propeller combination.
In Germany, Fritz von Opel had in 1929 constructed an experimental aircraft to demonstrate that powered flight without a propeller was a feasible proposition. Opel used a number of solid fuel rockets to power a glider. It flew just, but its maximum duration of 10 minutes hardly foreshadowed an aerodynamic revolution. Opel's experiments made no impression on the aero engine manufacturers, who continued to construct their heavy, intricate piston engines. They're now employing the new technique of supercharging, that is, using impellers, high-grade paddle wheels driven by the engine, to pump the petrol-air mixture into the cylinders in an attempt to maintain sea-level performance in the thin air of high altitude. However efficient the designers and metallurgists made the power plants, the weak link at high altitude, the propeller, remained. Searching for an alternative, Frank Whittle at first considered using a piston engine to drive a compressor, pumping air into a jet pipe with burners, but he rejected the idea as hopelessly inefficient, which indeed it was. That proposition had been one considered in his Cranwell paper.
I didn't have the complete idea then. I was just groping towards it. Then in 1929, the penny dropped, and the idea of the turbojet came to me.
But the principle of jet propulsion had been discovered much earlier in 120 BC by Hero of Alexandria. His engine consisted of two small jets angled from a globe of silver, fed by a boiler through supporting pillars. With pressure up, the steam jets propelled the globe. Thus man's first known heat engine was jet-propelled. 1600 years later, Sir Isaac Newton formalized the effect as his third law of motion. For each action, there exists an equal and opposite reaction. And if James Watt's celebrated observation of the boiling kettle's lid had applied Newton's law instead to the spout, he could have invented the turbine. Like this simple steam turbine, the gas turbine which Frank Whittle proposed is extremely simple, having only two major moving parts. The compressor wheel on the left and the turbine on the right, both keyed to a single shaft and housed within a pressure casing. The compressor's impeller forces air into the casing, which also contains a number of combustion chambers in which fuel, kerosene, is continually burnt. The expanding gases resulting from combustion pass through the turbine, turning it at very high speeds, up to 17,000 RPM, before exhausting from the jet pipe with enough velocity, 1,000 pounds in the early engine, to push the aircraft forward in powered flight. In 1930, that was still all theory. Undaunted, Frank Whittle patented his gas turbine on the 14th of October in that year. The high-speed monoplanes, which could conceivably utilize a jet engine, now existed, at least in prototype. But Frank Whittle knew that to construct a practical gas turbine aero engine was going in many ways to be a much more formidable undertaking. The massive 36-litre Rolls-Royce engine, which had powered the Schneider Trophy seaplanes, had required the most intensive research, not only into the very special chemistry of the fuels, but also into the then unknown territory of high-pressure supercharging. Rolls-Royce, with the aid of the Royal Aircraft Establishment, finally, after a great deal of work, managed to achieve a supercharger that could efficiently compress the mixture to twice sea-level atmosphere, and that in 1929 was considered to be very good going indeed. Frank Whittle had calculated that for his gas turbine he would require a much larger and far more efficient compressor, working at 4 times that pressure. The calculations for the compressor were included in a paper which Whittle wrote to prove the case for the gas turbine. But none of the aero engine manufacturers were in the least interested in his proposals, at a time when meagre orders for existing engines were hardly sufficient to keep the firm solvent. One obvious conclusion drawn from the Schneider Trophy was that the days of the biplane were numbered. The Air Ministry was therefore experimenting with monoplanes like this long-range Fairy. To spend the money instead on exotic engines, which could at best take years to develop, was out of the question. So to cool his ardor, the Air Ministry posted their young inventor to the Marine Aircraft Experimental Establishment at Felixstowe to discover how a land plane behaved in water. Frank Whittle also made 47 experimental catapult launches. One was to prove memorable, where his passenger was thrown out but managed to grab hold of the tailplane as he left.
I took a quick glance over my shoulder and I saw there was a body on the tailplane, but I didn't know it was my passenger. Until I found I wasn't losing control entirely. I'd got the stick right forward, full throttle. I took a more collected look and saw that it was my passenger, who then was struggled round into a sitting position with his back against the fin wire. And when he saw me look round with his helmet blowing out and his cheeks blowing out, he gave me a thumbs up sign with his spare hand. The other one was holding onto the fin. And I saw him go, okay. I thought to myself, well, you may think you're okay, old boy, but we can't get down. Because every time I tried to pull the throttle back, I couldn't hold up his weight.
He couldn't turn either due to his passenger leaning on the rudder, which was embarrassing since a German liner was dead ahead. The question was,
could I get back onto the water before I flew into the side of the ship? I managed it. The German ship turned to port, which was taking a bit of a risk in those shallow waters. This was just off the Isle of Wight.
In the summer of 1932, Whittle was posted to an engineering course at Henlow, which he passed with 98% marks. He then went up to Peterhouse College, Cambridge, to read for a mechanical engineering tripos. During those 4 years of study in that biplane era, Frank Whittle deplored the lost opportunities and had, by 1936, begun to face up to the reality of the continued rejection of his gas turbine engine.
I began to think it was before its time. In fact, I allowed the patent to lapse. And then along came Dudley Williams, now Sir Ralph Dudley Williams, or at least he wrote to me first, And then I saw him afterwards. He said he thought he could raise some money to get the thing going. And he and a partner did, in fact, manage to contact a small outfit called, commercial bankers called Falcon Partners. And they agreed to put up some money. And as a result of that, Power Jets was formed in March of 1936. But before the company was actually formed, Falcon Partners agreed to place an order with the BTH for the manufacturing drawings of an experimental engine.
To this day, Sir Frank still has the original drawing board, which was in 1936 Power Jet's principal asset.
The first jet engine was drawn on that. The BTH first drawing I wasn't satisfied with, so I did a half-scale drawing on this board, and that was the basis of the experimental engine. Power Jets had no staff except me, and I was on loan from the Air Ministry as a squadron leader.
So the initial practical work was contracted out to the British Thomson Houston Company at their Rugby steam turbine works, where gradually the strange engine took shape. Casing, combustion chamber, the impeller of the compressor, and the turbine. By the 12th of April 1937, the engine stood complete and ready for testing. The question nobody liked to ask was, would it work?
When we first tried to start it up, we certainly succeeded. I was on the controls, and we got the thing running up to 1,000 RPM, and I got a signal from one of the fitters that there was a light up in the combustion chambers, and I signaled for the speed to be raised to 2,000 RPM, which was done with an electric motor. And then I opened the main fuel control to get it going under its own power, and it certainly did. It accelerated out of control, and so did everyone standing around. Except me, I was paralyzed with fright. I thought maybe we'd got something which we couldn't control. It went up to about half full speed, up to about 8,000 RPM, and then, fortunately, stopped accelerating. The reason was that there was a lake of fuel had collected in the combustion chamber, which we didn't know anything about.
On its second run, the engine seized solid at 12,000 RPM. It was rebuilt and then run up to 13,000 RPM, with, Sir Frank remembers, a noise like an air raid siren. After those early test runs, the BTH management, not unreasonably, decided that a move to a rather more rural location was perhaps desirable. In the village of Lutterworth, the company owned a derelict property known as Ladywood Works, the name being a great deal grander than the location.
Oh, God, it was terrible. It was an old, disused iron foundry. They were rickety old floors. Old Whittle had an office rather like a rabbit hutch, you know, and it was a really terrible place. It had one test bed, as I remember. I can't remember what the workshops were like, but it was a pathetic setup, really.
With delays caused by the move and the chronic shortage of everything, especially money, it took a year to rebuild the engine, which seized up, to be yet again rebuilt in its third and final form, to become the prototype of the engine which would eventually fly, with the 10 interconnected combustion chambers. These were to prove one of the most difficult components of the engine to get right. This is that original Whittle engine, the first in the world to run, now preserved in the Science Museum, London. Incredibly, in spite of being constructed from salvaged parts, it ran remarkably well.
It was getting up to speeds of about 16,500. By the time we were getting it to this stage, it had been through so many mishaps that it was really a heap of junk. And so when I look back on it, it rather surprises me that we got it up to 16,500.
That was in June 1939. By then the Germans had annexed Austria and the Sudetenland of Czechoslovakia. The Munich crisis of September 1938 had passed, and of the peace in our time, then predicted by Neville Chamberlain, just 3 months remained. Since 1933, when Hitler first came to power, the Luftwaffe had been training and growing, secretly at first, then openly, until by 1938 it was revealed to have achieved and surpassed parity with the RAF. there was to be little doubt as to the quality of the Luftwaffe. For example, the Stuka dive bomber, which was soon to spearhead the Blitzkrieg, and the Ju-88, conceived in 1935 as a Schnell bomber, a bomber with the performance of contemporary fighters. To counter the Luftwaffe expansion, the RAF began to rearm. In 1936, the prototype of R.J. Mitchell's Spitfire had flown, as had the Hurricane, and both were now in full production to re-equip the fighter squadrons of the RAF, many of which were to fly biplanes until mid-1939. In the 12 months' grace between Munich and the outbreak of war, the long years of neglect of the RAF were to some extent made good. By September 1939, Fighter Command was at last equipped with modern aircraft, backed by an efficient radar-based fighter control system, and was considered to be able to counter the Luftwaffe. However, if anyone at the Air Ministry had thought that the German aero engine industry might have made the transition from their turbo superchargers to a gas turbine and be producing a German jet, then their appreciation went unheeded. In point of fact, the Germans had already made that step. It was the experimental Heinkel 178, powered by a jet engine designed by a young physicist from Göttingen University, Hans Pabst von Ohain, who in 1936 had approached Ernst Heinkel with a proposal to build a gas turbine. Heinkel agreed to provide the facilities and finances for von Ohain to build an experimental turbine which ran on hydrogen. The turbine produced only 176 pounds of thrust, but it impressed Heinkel sufficiently for him to back the development of a flight engine. With the backing of a large aircraft factory, the engine, similar to Frank Whittle's, was built and bench-tested by the winter of 1938. On completion, the engine was installed in the specially built HE-178, which was ready by the 27th of August 1939 to make the world's first gas turbine-powered flight. Von Ohain remembers the day well.
Well, we had a short airfield. Wasitz had already, the day before, taxied the aircraft, and he thought he could make it. It was an early morning, slightly foggy, but only very slightly foggy. And he accelerated. It worked without any problem. He lifted up, and then we lost him because he went on straight, and we didn't hear anything anymore. And so we waited, and then 5 minutes, a very long time, then he came back, then he curved around, and we wondered why he is not landing. And so we felt, oh, he feels very good there. But the fact was that he couldn't really see, because the glare of that fog, he said, was terrible. The sun came up, and when he wanted to land, it was such a glare he couldn't really exactly see the airfield. So he made several rounds until he could really safely set down.
Test pilot Wasitz, Heinkel and von Ohain celebrated with a champagne breakfast, perhaps a little prematurely, for 5 days later Germany was at war. In stark contrast to the plenty enjoyed by von Ohain, Frank Whittle struggled with his single battered engine and was in those last weeks of peace suffering from an early example of catch-22.
Because the Power Jets was on the point of going broke, the Air Ministry was very reluctant to place any contracts, you see. They thought the firm was too rocky. And, but we were getting small contracts, you know, £5,000, and then they paid for the second reconstruction of the engine, about £2,400, and altogether, by the time the engine was showing signs of being worthwhile, we'd spent about £20,000, all told, private money and Air Ministry money. But the real turning point was when the Director of Scientific Research came to Lutterworth, where we were testing the engine, and saw it run up to 16,500 RPM, and he became, for the first time, completely sold. Up to that time, they'd been paying the money on the basis that the job was really long-term research.
One result of that official visit was that all of Power Jet's work became subject to the Official Secrets Act, which made raising capital even more difficult. But the Air Ministry had at least bought the long-suffering original engine and had placed a contract for a flight engine, the W.1, to power an experimental aircraft which the Gloster Company were to design and build, the Gloster Whittle E-2839. But it was still on the drawing board when the Second World War broke out, and all that Power Jets had was a model. The war, at first, at least in Britain and France, called the Phony War, was soon to change, to become the reality of Dunkirk and the Battle of Britain. That summer, Frank Whittle and his small staff still had the problem of finding an established aero-engine manufacturer, for although the E-2839 had yet to fly, it now had a successor, a twin-engine fighter, eventually to be named Meteor, to follow the purely experimental Gloster Whittle. The obvious choice, Rolls-Royce, were like the other major companies fully stretched, supplying aero engines for war production. Another difficulty was Frank Whittle's concern that a big company might absorb Power Jets, whose patent position was far from satisfactory.
The patent position was not strong. The first master patent having lapsed. We had several other patents, but I didn't think that the patent position was very strong. So we were looking for subcontractors who were not likely, as we thought, to start competing with us. And it's happened that the wife of one of our directors was a friend of the wife of a director of the Rover company, and as a result of that, we invited the Rover company to act as subcontractors to us, which they agreed to do. The Rover company, I'm afraid, made a shambles of the job, and their behavior was, I think, absolutely disgraceful. They were out to get direct contracts, which they succeeded in doing. They did all sorts of dirty tricks. For instance, they got permission from the ministry to be responsible for the drawings. Well, on one occasion, manufacturing drawings, on one occasion we asked them to let us have a drawing of the compressor casing. And when it came, we found that it was, you might say, a breach of copyright, because it was a photostat of one of our own drawings with all reference to Power Jets removed, as though it were a Rover company drawing. But unfortunately for them, they'd left in the bottom right-hand corner the names of our draftsmen, so that it was pretty obvious that it was merely a photostat of our drawing. And after that, I became much keener on getting a Rolls-Royce into the picture.
The first Rolls-Royce man to visit Power Jets was Stanley Hooker.
Well, it was in January 1940 when Hein Constant, who was the Director of Engine Research at the Royal Aircraft Establishment, took me to Lutterworth to see the engine. I'd never heard anything about it before. Constant used to come to Derby to discuss the Merlin supercharger with me. And one day he said, I'm going to take you to see this jet engine, which was secret at the time. I met Whittle, and then he showed me his engine and discussed it with me, described it and so forth. And I can't say I was an immediate convertee to jet propulsion. I hadn't really studied it sufficiently for that. But I must say that standing by his engine when it was running, and they used to run more or less in the open in those days, one always had a sensation here was tremendous power, you know.
Stanley Hooker's brilliant work on the supercharger for the Merlin shared common ground with Whittle's jet compressor.
Lutterworth wasn't very far away, of course, only 30 miles or so. And I, having met Whittle and got on very well with him from the beginning, I used to go and see him fairly frequently. In fact, I used to take him Merlin supercharger the results to look at, because, you see, he had no tests of his own supercharger. There wasn't a plant big enough in the country to test it. So I used to take him these things, and we had a lot of discussion. And eventually, when his engine was running at about 1,000 pounds of thrust, I went to see Hives, Lord Hives, or Mr. Hives as he was at the time, and tried to persuade him to go to Lutterworth and see the engine. And he said, what does it do? And I said, well, it's giving about 1,000 pounds of thrust. Well, now, we were all used to horsepower. We knew the Merlin gave 1,000 horsepower more. And one must admit that 1,000 pounds of thrust doesn't sound much compared with 1,000 horsepower. And Hives turned to me and said, well, that's not much, is it? You know, they wouldn't pull the skin off a rice pudding, would it? And I went away and did a sum, went back to him and said, do you know how much thrust the Merlin gives in a Spitfire? And he said, no, how much? And I said, 1,000 pounds. And he immediately rang for his secretary and said, I'm going down to see this engine with Hooker on Sunday.
And what was Hives' impression?
Oh, he went down, he came, he saw he was conquered, you know, it was literally that, really. He didn't say much, he walked around, and Whittle described it all to him, gave him proper tour. At the end of it, he turned to Whittle and said, I don't see many engines about, Whittle. He said, why haven't you got more engines? And Whittle said, well, I look at the facilities I've got. I can't get anything made, I can't get this, and I've got no money, and so on and so forth. And Hives turned to him and said, well, send us the drawings and we'll make the stuff for you. And we made quite a lot of components at Derby for Whittle to help him with his job.
The Battle of Britain was by then at its height. The epic victory of the Spitfires and Hurricanes requires no retelling here, but it is pertinent to ask, if Frank Whittle had been better supported, could a developed British jet have made any difference to the struggle? In the absence of German jets, probably not. During the battle, there was never a shortage of RAF aircraft, but of pilots, and the existing Spitfires and Hurricanes carried the day, which was just as well, because the Gloster Whittle was not rolled out until the spring of 1941, fitted with a non-flight Whittle engine, the W.1X, to commence taxiing trials.
It was really a lash-up engine, which is why we call it the W1X, W1 Experimental. And that was used for the taxiing trials of this aeroplane.
It was taxied at Hucklecote on the 7th of April 1941 by Frank Whittle. He opened the W1X engine to 13,000 RPM, but the grass airfield was soggy and the best speed obtained was a mere 20 miles per hour. The next day, Gloucester's test pilot opened up to 15,000 RPM, and it was clear that the flight engine should provide adequate thrust for flight. As it was, it would seem that the W1X also had hidden reserves, as witnessed by Bob Fielden.
Then the pilot, Jerry Sayre, did just a short hop on the grass airfield, jet-propelled. So it really was one of the moments of my life. And I might record that afterwards, one of the other pilots, Mr. Michael Daunt, said to me, "Thank God it flew straight." I said, "What on earth do you mean?" He said, "Well, we all thought it was going to squib around like a squib firework."
The W1X engine used for the taxiing trials was removed from the aircraft and sent to the United States, and the 1,000-pound thrust W1 flight engine was installed in the prototype. Ground running had proved that the W1 engine would have no difficulties providing the minimum thrust, around 900 pounds, required for flight. This unique colour film of the original E-2839 was taken by our Power Jet's engineer, Matthew Nathan, after the first flight made at Cranwell just 40 years ago.
On the day, 15th of May, 41, the weather during the day was too bad for other than taxiing trials until the evening. And then Jerry Sayre just tweaked the end of the runway, ran it up to the maximum speed that the ministry would permit, which was 16,500, holding it on the brakes, let go of the brakes, and he was off in 600 yards, and just disappeared from sight in the clouds, and was flying for about 17 minutes, and then came in doing quite steep gliding turns, as though he'd been flying the airplane for weeks.
There were depressingly few to witness the event, and the only known record of that historic occasion is a still photograph and a fragment of 16mm.
Frank, it flies, and my I suppose I was tense or something, and my comment was, well, that was what it was bloody well supposed to do, wasn't it?
The marked lack of official interest on the occasion of the first flight still rankles with Sir Frank 40 years on.
Only a group of, from Power Jets and a group from Gloucester's, and the group from Power Jets included the resident technical officer from the ministry. But there were no official representatives, and what I think was rather a scandal, there was no attempt to make any official films of the whole affair. And so no good film of those first flights exists.
By contrast, there exists excellent film of Germany's second jet, the twin-engined Heinkel 280. The construction and first flight of their original jet, the 178, had been so secret that not even the German Air Ministry had been aware of it. After the successful test flights became officially known, orders for 9 prototype 280s followed, with the promise that if satisfactory, substantial production orders could well follow. In a remarkably short time, von Ohain, backed by the full facilities of the Heinkel works, had designed and built a new turbojet, which gave 1,250 pounds of thrust on the bench to power the new aircraft, itself in many ways a most advanced concept which can claim a number of firsts. It was the first twin-engine jet, the first with a tricycle undercarriage, and the first to fit and later to use an ejector seat. The 280 was the second jet in the world to fly. The first prototype, this is actually the third, had flown from this runway at Marianair, the Heinkel Company factory airfield, on the 2nd of April 1941, 6 weeks before the British jet, the Gloster Whittle, was to fly. It's instructive, therefore, to see the progress that could be achieved given adequate backing, and there is no doubt whatsoever that if Whittle's project had enjoyed the same facilities, the Meteor could also have flown by this time. Although the 280 achieved over 500 miles an hour and bettered an FW-190 in mock combat, no mean achievement, it did not, for political reasons, go into production. Neither did von Ohain's engines. The sole Allied jet in 1941, the E-2839, was, after its inaugural flight, extensively used to test fly a new Whittle engine, the W2B, installed in the Meteor. The E-2839 proved to be capable of 440 miles an hour with an absolute ceiling of 56,000 feet, fully vindicating Frank Whittle's early claims for turbojets. However, the Whittle W2B was to prove a most difficult engine to develop.
I think many members of the team wished that we had gone ahead with the W1 air-cooled engine, W1A, rather than pushing ahead with the more advanced W2 series of engines, because the W1 engine had flown successfully, 10 hours flying with a brand new aircraft, brand new propulsion system, and never with the engine covers open once. And that, I think, must be an all-time record in aviation.
That success of the E-2839 led in some ways to an over-optimistic program for the Meteor. The ministry required 1,200 Whittle engines and 500 airframes. The question concerning Frank Whittle was who was to produce the engines. Relations with the Rover company were then so bad that S.B. Wilkes, the managing director, went to Rolls-Royce to see his old friend Ernest Hyde.
Hives sent for me one day and said, look, we're going up to Clitheroe tonight. We're going to have dinner with S.B. Wilkes. He didn't say why. So off we went, and we had dinner in the Swan and Royal in Clitheroe, old pub there. And after dinner, old Hives turned to Wilkes with his usual abruptness and twinkle in his eye, always did it humorously, really. He said, you know, you're making a hell of a mess of this jet job, aren't you? You don't get on with Whittle. And Will said, yeah. He said, well, I don't know what you're doing with it. He said, you grub about on the ground, you know. It's an aircraft engine, it's our meat, not yours. I'll tell you what I'll do. I'll give you our tank engine factory at Nottingham. You give me this jet job. And Will said, I should be glad to get rid of it. And so we got all the Rover facilities at Clitheroe and Barnoldswick.
And that memorable dinner got Rolls-Royce into the jet aero engine business.
In the light of subsequent history, it was a remarkable dinner altogether. It was one of those 5 bob ones, you know, wartime 5 bob dinners. I can't remember whether Hives paid or Wilkes paid. I expect Wilkes did. Old Hives didn't would pull that one over, I expect. But it was a fantastic deal for Rolls-Royce as things turned out.
Next day, the two men went to the Rover jet production factory that Rolls-Royce had just acquired.
And Hives looked around and said, this will do as the experimental shop. Forget about production. We've got to get this engine right first, and then we'll produce it as easy as easy.
The resources of what was, and arguably still is, the greatest producer of aero engines in the world was now at the disposal of Power Jets, with foundries able to cast intricate parts in steel or high-duty alloys, virtually unlimited stocks of high-grade steels and other metals, together with a large and highly skilled workforce able to utilize to the full the facilities available. A certain urgency was now attached to jet engine production. Mosquitoes of the RAF photographic reconnaissance units had been bringing back disquieting evidence, wispy outlines of unknown delta-winged aircraft and scorch marks on the grass airfields at Lechfeld, Peenemünde and Rechlin, the German equivalent of Boscombe Down, where this photograph was taken. These scorch marks were known to have been made by experimental jet aircraft. They could well have been made by the Messerschmitt 163, a lineal descendant of Opel's amusing rocket glider. The delta-winged 163 Comet, powered by a lightweight, liquid-fueled Walter rocket, had been designed as an interceptor fighter and possessed a truly amazing rate of climb. In October 1941, the prototype had broken the existing world speed record at over 623 miles an hour on the edge of the sound barrier. Rocket planes apart, a new jet was being tested in Germany by 1943. It was the Arado 234 Blitz bomber, the only jet bomber to see service in World War II, which it did during the Battle of the Bulge. But fortunately for the Allies, the 234 had suffered from a common weakness of German wartime research: too little and too late. Hitler had banked on a short war. By the time it was clear that this was not to be, there was insufficient time to develop the promising early prototypes, which in 1941, with victory scented, had been postponed. But there was another fundamental reason for delay. The Arado, for example, had been held up for 12 months, while the Junkers company under Dr. Franz were developing their jet engine, the Junkers Umo 004. It was certainly an advanced concept, an axial engine, that is, the simple, reliable Whittle-type compressor being replaced by these multiple blades, a difficult engine to get right even today, but it was theoretically more efficient, presenting a smaller cross-section, important in high-speed flight. Two were fitted in Germany's most successful jet fighter, the Me-262. The first flight was from the Messerschmitt factory airfield at Liebheim near Ulm. The date was July the 19th, 1942, and the pilot, Flugkapitän Fritz Wendel, who, in the absence of a propeller slipstream over the elevators, had to apply the brakes at 112 miles an hour as he passed a white line across the runway. He was later to report, "Immediately I touched the brakes, the tail lifted. The turbojets ran like clockwork, and indeed seldom have I been so enthusiastic during my first flight of a new aircraft." In fact, the 262 was tricky. The first two prototypes had flown with piston engines. This, the third prototype, was the first to fly on jet power alone. It had engines which required very careful handling. Too much throttle and the turbines burnt out, or the compressor stalled. Another unpleasant characteristic of those early axial engines was a pronounced lag in throttle response, which called for a very carefully judged landing approach. After the 17-minute first flight, test pilot Wendel slipped past the Gigant gliders that had been constructed in 1940 for the invasion of Britain, with just enough power on for a perfect approach and touchdown. But the moment he closed the throttles, no doubt in some relief, both jet engines immediately caught fire due to excess fuel igniting in the jet pipes. The fires were soon put out, but they were an omen of long delays caused by Luftwaffe indifference and later Hitler demanding that the fighter be capable of carrying bombs. There were other problems with the engine, and 262s were not to see action until October 1944 to intercept the high-flying B-17s of the US Army Air Force. Out of 1,500 built, there were probably fewer than 100 262s operational and never more than 15 serviceable at any one time, all flying with engines that were so underdeveloped that more 262 pilots were lost in flying accidents than in action. Nevertheless, had they been available in sufficient numbers with an engine as well developed as Whittle's, they could have made even the losses to the US 8th Army Air Force unacceptable. As it was, they joined the Luftwaffe's piston engine fighters in the great air battles over Germany in 1944, and 262s accounted for at least 100 American bombers shot down.
I see him. At 2 o'clock. Watch him, Scotty.
At that time, the only operational Allied jets were 16 Meteor 1s powered by Rolls-Royce Welland engines developed from Whittle's design. The aircraft were hastily converted from a training to an operational role for 616 Squadron, the first in the RAF to fly jets, to intercept the very fast V-1 flying bombs. The first jet versus jet combats followed during the summer of 1944, though admittedly they were a little one-sided. The first American jet, the Bell P-59 Air Comet, was powered by 2 General Electric engines which were American copies of a Whittle W.1. The General Electric Company had built their version in just 4 months, but too late to see service. In September 1944, the Minister of Aircraft Production, Sir Stafford Cripps, visited Power Jets, and Whittle suggested the nationalization of the entire jet aero engine industry.
What I visualized was a single cohesive unit with Power Jets at the hub of it, you see. And I even thought it possible that I would be the chief engineer of the whole business, since we'd started it, and our engines were, in my opinion, still the best.
Sir Stafford came, saw, and confiscated. The only company to be nationalized was Power Jets itself, whose staff thus became civil servants. It was a blow to Frank Whittle, for with the end of the war within sight, the Miles Company had designed the M.52, which was to have been Britain's first supersonic research aircraft, to be powered by a Whittle-designed engine, which would have been the first ducted fan. This and other projects were under intensive development. But the fate of the M.52 project began a fashion to be followed by successive governments. In February 1946, when the design was 97% complete, it was cancelled, along with all the other advanced engine projects of Power Jets, which was to become simply a test facility for other companies' engines.
We were forbidden to design and make engines, and so that the people who'd started the whole business were robbed of the right to design and build engines.
Frank Whittle resigned from the board of Power Jets and retired from the Royal Air Force as Air Commodore. Most of his staff followed him and scattered throughout the industry at home and abroad. Thus, when the new shapes, some owing much to German high-speed research, were shown at the early post-war Farnborough shows, the major responsibility of British aero engine design and construction had passed to other hands. Frank Whittle's brilliant pioneering work was to give Britain its world lead in jet aero engine technology. It was, in the early post-war years, made freely available to all. Sir Stafford Cripps gave Rolls-Royce Nenes to Russia to found their jet engine industry and to power their MiG-15s over Korea. Britain's second jet fighter, the de Havilland Vampire, was begun during the war, but too late to see service. At the 1949 Farnborough, the de Havilland Comet was shown to the public. It was the world's first civil jet airliner, and although tragically flawed, was the herald of the jet age in which, sadly, Sir Frank Whittle was to take no practical part. Although knighted and rewarded, he remains bitter to this day.
Oh, yes, I am. But most bitter about firstly, the fact that the policy mismanagement delayed the use of the engine in the war. It did go into operation, but in quite a limited way. Didn't have any material effect on the war. I was bitter about that, because it needn't have been so. And but even more bitter about the removal of my right to design and make engines. And one consequence of that was that the ducted fan, which is now practically universal, turbofan, was delayed for at least 6 to 10 years.
I was quite astonished to know what it was because it had no propeller.
And John replied, "Oh, it's easy, old boy, it just sucks itself along like a hoover." There was the awful race against time. There was the skullduggery.
She used to say, "Oh, well, Daddy's doing something very hush-hush."
I thought, my goodness, why didn't I think of this before? And it seemed so obvious then.
A small English church is the last resting place of a man who didn't just change the face of the earth. He enabled us to see what it actually looked like. His name was Frank Whittle. This is the story of how he invented the jet engine. He overcame all the odds, only to see the British government almost throw his idea away and miss a chance to shorten the Second World War.
I was born on June the 1st, 1907 in Coventry. My parents were working class. My father was a foreman in machine tool manufacturers. I lived there in Coventry for 9 years, went to an elementary school there. And then the family moved to Leamington Spa because my father bought a small, very small, engineering outfit called the Leamington Valve and Piston Ring Company. And I really did get my first engineering experiences there because I helped him sometimes for, I think it was about twopence an hour or something like that, making slots in valve stems.
In Leamington, Frank also won a scholarship to the town's secondary school.
I was very lazy with homework and got a series of raspberries for that. But at the end of term, I would often do quite well. For instance, I'd come top of maths, something like that. I never did win a prize at school. But I did an awful lot of private study. I used to go down to the library in Leamington Spa and study all sorts of things which are not in the school curriculum. And that was where I first started to learn about gas turbines. I was always attracted to flying from my earliest years almost. When I was 4, my favourite toy, and this was 1911, was a tin model of a Blériot. And my heroes were people like Captain Albert Ball and Major McCudden and so on, the VCs of the First World War, and I just wanted to fly. And also I thought that boys in the uniform of aircraft apprentices looked very good, so I decided I'd like to wear that uniform and applied to join as an apprentice.
The Royal Air Force, however, rejected young Whittle. He was too small.
I was sunk for the time being, but before I left the camp, a very kindly physical training sergeant, if you can imagine such a thing, took pity on me, and he gave me a diet to follow and a series of exercises, max holding exercises. I did all that for 6 months. I put on 3 inches on height and 3 inches on my chest. So I thought, well, I'll have another shot. And I wrote to the ministry, but they said, no, once you've been turned down, you've been turned down forever. So I thought, well, I'd go through the whole process again as though I'd never happened, in the hope that the bureaucracy wouldn't pick it up. And I was lucky that time, and ended up at Cranwell in number 4 wing.
Whittle didn't enjoy life as an Air Force apprentice. In that rank, he would never get to fly. What brightened Whittle's life was the Model Aircraft Society, where he became the leading light at building working replicas.
So much so that the initials BWMAS, which stood for Boys Wing Model Aircraft Society, was, most people said that meant Boy Whittle's Model Aircraft Society, because we were known as Boy Whittle, Boy Smith and so forth in those days.
Whittle's skills at making model planes singled him out to the authorities. Perhaps he might be officer material.
There were to be 5 cadets selected from number 4 wing at Cranwell, and I was number 6 in the passing out list. So when the number 1 boy failed because of his eyesight, it made me eligible.
The founder of the Royal Air Force had his doubts, though.
Lord Trenchard nearly stopped it, because I hadn't been a leading boy and I hadn't made no kind of a name in sports, on which a lot of weight was put in those days.
Whittle's CO had a compelling reason to make Trenchard think again.
He thought that he'd got a mathematical genius.
It was this natural gift that got Whittle a cadetship. Less than 1% of apprentices made the huge step to join the elite in the Officers' Training College at Cranwell. Although this was next to the apprentices' wing, it was socially another world, one that shared the culture of the public schools from where most of the cadets then came. In the bleak Lincolnshire countryside, Frank Whittle's life now took a new direction. Cranwell provided a very intensive education for Whittle. For the cadets, just as it is today, the highlight of the course was the flying lessons.
I learned to fly on the Avro 504K. That was a very ancient type of aeroplane, 1911 type, and it sort with a toothpick between the wheels, you know, to prevent it tipping over on its nose, which in reality it helps it to tip it over on its nose, or even turn upside down.
Whittle was soon a daring, even overconfident pilot, and one who had his fair share of accidents.
I have to confess that I wrecked 2 or 3 aeroplanes. 3 at least, yes. The first one, I got lost and wanted to get back to Cranwell when the visibility had deteriorated very badly. It was the day, incidentally, of the cross-country run at Cranwell, which all cadets hated. And most of my fellow cadets thought I'd done it to get out of the cross-country run.
In between learning to fly and studying at Cranwell, Whittle first conceived the idea that would make him famous. It all started with a student thesis.
All cadets had to write a thesis, and I chose future. But the main thing in that thesis was that I arrived at what I now know was the well-known Breguet formula. I wasn't familiar with it at the time, connecting speed, range, engine efficiency, and so forth. And to me, that meant that if you wanted to go very fast and far, you would have to go very high, heights of 50,000 feet, that sort of thing, at heights where the piston engine obviously wouldn't work, and at speeds where the propeller wouldn't work. So I started to look for a new kind of power plant.
Whittle prepared this paper during the first half of 1928, but his findings at Cranwell were the fruit of the 5 years he had by now been training there.
My Cranwell thesis, when the professor marked it, he wrote on it, in effect, he didn't really understand it, but he gave me 30 out of 30, which I thought was quite satisfactory.
Whittle envisaged flying speeds of 500 miles an hour, at a time when propeller planes struggled to reach 150. These machines were noisy and shook the pilot terribly. That's because their engines were actually car motors on a bigger scale with many moving parts. Whittle felt an aesthetic dislike for such power plants.
The problem with the piston engine as you go up height, even though you supercharge it, is that the power drops off as the air gets thinner, and there eventually comes a point where it won't generate enough power to turn itself over against its own friction.
Whittle's idea would use the same principle as a balloon filled with air. When this escapes, every child knows what happens. But it wasn't clear how an engine might recreate such a force.
I considered a piston engine driving a fan inside a hollow fuselage, and then thought, well, why not throw that piston engine away, up the compression ratio of the fan, and substitute a turbine for the piston engine? And there was the turbojet.
By now, Whittle had left Cranwell, but his search for this solution had preoccupied him ever since.
It didn't come to me out of the blue for the simple reason that I've been trying to find it for 18 months. But just the thought, get rid of the piston engine and substitute a turbine, you might say that came out of the blue. Whether I was having a bath or whatever at the time, I couldn't tell you.
Whittle's plan proposed just one moving part. This would be a shaft with a compressor, driven by a turbine at the other end. It would work like this. The compressor spins round, sucking air into combustion chambers at many times atmospheric pressure. Here, this air is mixed with vaporized fuel and ignited. The hot gas created expands through the turbine, turning the shaft, and escapes into the atmosphere. It is this continuous force which propels a jet aeroplane along. The turbojet concept brought with it so many natural advantages.
A very big factor in favour of a jet engine was that when you went up high, the air temperature was very low, very cold, and that benefited the compressor a lot. It meant that you could get much better conditions for the compressor. And the other thing is that in a normal turbine, the velocity coming out of it is wasted. In the case of the jet engine, that was completely used. After the idea had come to me, I thought, oh, my goodness, why didn't I think of this before? And it seemed so obvious then.
This was Whittle's moment of genius. He had seen the future of powered flight, and he was a pilot officer, aged just 22.
I was at the Central Flying School at Wittering, doing the flying instructor's course. One of the instructors there was W.E.P. Johnson, who became a very good friend and colleague in later years, and he'd been trained as a patent agent. And he became very interested in my proposal. He thought it would work, and he helped me to draft a patent.
Have you ever patented anything?
No, I don't know a thing about it. Does a patent both publish and protect?
That is the whole point of patents. But one thing's essential. File a patent application before touting the thing round. Otherwise, you haven't a hope. I'll tell you what, let's rough out a specification now.
Oh, what? Fine. What do we do?
Well, you make a rather better sketch, and I'll get on with the clever bit, the writing.
Okay.
Armed with his patent, Whittle offered his idea to industry. No one thought it could ever work.
According to the theories of the time, there was this fundamental difficulty with gas turbines, inefficient compressors, inefficient turbines, and the other big snag was the materials then existing in 1929 wouldn't stand temperatures of more than, say, about 500 degrees centigrade. But I knew, or felt pretty confident, that they would evolve in the normal course of development, and of course they did.
The positive young officer also went to London to put his revolutionary concept to the Air Ministry. Whittle fared no better when he met A.A. Griffith, one of the ministry's top scientists.
I went to see Dr. Griffith and another scientist at South Kensington, explained the idea. It was very coolly received. Griffith pointed out an error in my calculations, and it was all rather depressing, you know. And then after that, I got a letter from the Air Ministry saying, in effect, that they weren't really interested and so forth. It didn't help that I hadn't then received an engineering degree.
Soon after this rejection, Whittle seemed to have more bad news.
After I completed the flying instructor's course, I very nearly got posted to number 4 FTS, Abu Sweir in Egypt. That would have been a real nail in the coffin of the jet engine if that had happened.
Fortunately, the posting was changed. Whittle remained in Britain and served a year as a flying instructor. These were happy times for him. In May 1930, he married Dorothy Lee. During this period, he also got the chance to develop his exceptional flying skills. He was now one of the RAF's best pilots and was chosen to fly in the Hendon Air Pageants, where he thrilled spectators with his skills at crazy flying. These were the red arrows of the day, and Whittle loved entertaining the public this way. At this time in Germany, a young scientist was eagerly looking forward to his first trip in an aeroplane. His name was Hans von Ohain.
I always dreamed about the beauty of flying. My first flight with a commercial airplane, I believe it was a 3-engine Yonkers, was a great disappointment. It was so noisy and so vibratory that I felt the piston engine and propeller is not the good propulsion system. The elegance of flying is destroyed by it.
The sight of smoke rushing from chimneys inspired von Ohain to think, if that force could be created by a turbine, maybe he could make a smoother aero engine.
High speed was not the primary goal. To me, the smoothness and low noise was more the starting point of my thinking. But as I thought about it, I noticed that, as a matter of fact, it will be capable of driving the airplane faster.
Britain's Air Ministry had declined to keep Whittle's patents a secret. Freely available, they quickly made their way to Germany, just as the Nazis came to power. These patents were widely read in German aviation circles, at the same time that Hitler was rapidly building a new Luftwaffe. Whittle's idea aroused no such interest in Great Britain, and his own jet engine remained stillborn. Yet the Royal Air Force was certainly keen to nurture its inventor.
After 4 years, every general duties officer had to specialise. He was given a choice between engineering, radio, navigation, physical training and so on. But I didn't get a choice because, having been pestering the Air Ministry with inventions, they just said to me, "You will be an engineer." Though they'd stopped sending officers to Cambridge, they decided that I should go. So I went to Cambridge in September 1934 to take the mechanical sciences tripos.
Once at university, Whittle applied every piece of learning to his idea for jet propulsion.
I had got the feeling, rather, that I might be ahead of my time. with the extra knowledge I gained at Cambridge, I did become rather more aware of the difficulties.
Then this letter arrived in the post, which says, "My dear Whittle, this is just a hurried note to tell you that I have just met a man who is a bit of a big noise in an engineering concern, and to whom I mentioned your invention of an aeroplane sans propeller, as it were, and who is very interested." He's jotted a note at the top of the original letter. He says, "This letter changed the course of my life and triggered a revolution in aviation." And it did, because this letter rescued the turbojet idea in this country from oblivion.
The writer was Rolf Dudley Williams, an old friend from Cranwell. He visited Whittle at Cambridge with another former officer named Collingwood Tinling.
And they approached me with the idea of forming a company and getting on with it, and they succeeded.
A merchant bank was the catalyst.
Falcon Partners were approached by an intermediary, an engineer named Bramson. Williams and Tinling got in touch with him, and he got in touch with Falcon Partners, and Falcon Partners commissioned him to write a report on the whole project, which he did, and it was wholly favourable. Bramson's report, you might say, was another of the big key points in the whole story. He'd been very much involved with aviation. He was a pretty skillful aeronautical engineer. And his report inspired Falcon Partners to go on with the job. And in March 1936, they formed the company called Power Jets Limited.
Whittle told his backers the project had a 1 in 30 chance of success. The Air Ministry quickly added another obstacle.
One clause said that I was not to work more than 6 hours a week on the job. But of course, that didn't operate as an effective control on me. I worked practically full time.
At Cambridge, Whittle also had to fit in the task for which he'd gone to university in the first place.
And I very much wanted first-class honours, so I had to work like hell because I was designing the jet engine and preparing for my finals at the same time. And that was a very difficult thing to do. I succeeded in getting my first, happily, and then was able to turn back to the jet engine.
Whittle approached a manufacturer in Rugby to build the world's first jet engine. British Thomson Houston made steam turbines. Whittle drove over from Cambridge, rehearsing what he'd say to persuade the huge company to accept a contract. He succeeded, when all he could offer them was £2,000, well below what his project really needed.
The proper scientific way to go about the job would be to build a compressor and test it, build a turbine and test it, build combustion chambers and test it, and then put them all together when the results from each were satisfactory. But the cost for that would have been about £30,000, and there was no hope of getting that amount of money. So the only thing to do was go ahead with the complete engine. What we were doing was trying to prove the engine right from the word go.
In a cavernous Rugby workshop, Whittle set to work on this huge challenge.
The BTH built the engine, and I stood over it more or less while it was going on. I felt that we were going to be all right as far as the simple centrifugal compressor was concerned. I felt that the turbine was going to be all right, but I was uneasy about the combustion problem because we were aiming at 24 times the kind of combustion intensity that was obtainable in those days. But the engine became ready for running proper on April the 12th of 1937. A lot of people said it wouldn't even turn itself over. What did happen proved the very opposite. I gave a signal with my hands to raise the speed with the electric motor to 2,000 RPM, and that was done. And then I opened the main control, and it started all right. its accelerator out of control, and so did everyone standing around it. They all went down the factory like the wind. I didn't, because I was petrified with fright. I just couldn't move. Of course it wasn't. The fact was that a pool of fuel had accumulated in the combustion chamber, which we didn't know about, and that was keeping it running after I'd switched off the control. Well, that sort of thing happened day after day. We had about 4 of that kind of runaway. Just after the engine first ran and we'd submitted a report to the Air Ministry, this was the subject of another report by Griffith, the man who turned the job down in the early days, and his report damned it with faint praise. He brought in all the difficulties, said that no propeller meant that we wouldn't have the slipstream to help us take off, and so forth.
Whittle didn't know that in Germany some people were by now far more willing to bet on his idea. One of them was Ernst Heinkel, a legend in his country's resurgent aviation industry. Von Ohain had been introduced to him.
He was alone in his villa in Warnemünde. He explained to me that he wanted to finance the whole thing by himself if it works. And he said, I have the best aerodynamicists, I have the best and best designers, and I want you to tomorrow to speak with them and explain your ideas. I loved the Baltic Sea coast very much. I sure would think that would be a nice place to work, and so I choose Heinkel. Additionally, I felt I was afraid to go to engine companies. I thought they were too much ingrained in their recip engines, and my model didn't work sufficiently good.
Heinkel's company was attractive for another reason.
The whole development was very inexpensive, but when we would have asked for more money, we would have gotten it. So money was not a problem.
By contrast, the Power Jet's kitty was empty. As the Nazi threat grew, Whittle had a war winner, yet Britain was set to abandon it.
There were several things which hampered progress. In 1937-38, the worst was the tight financial situation. Our financial backers began to get cold feet. They had, quite unrealistically, expected that within a matter of a month or two, we would have an engine capable of flying in the stratosphere. Well, of course, we had breakdown after breakdown, and they began to lose heart. And they did not produce the money that they promised. The Air Ministry were very hesitant to help because we were in financial difficulty. After we'd first run the engine and shown that it at least was self-driving, they did agree to a very limited contract.
The ministry's grudging help only created new problems.
As soon as they gave us a contract, we came under the Official Secrets Act. That meant that we couldn't tell people what we wanted their money for. You can't go to someone and say, look, we've got a damn good idea, would you let us have some money? We can't tell you what it is, but it's very good. No, we couldn't do it.
By 1939, Britain had spent just £7,000 on Whittle's jet. His very position on the project was perilous. At the end of June, he was actually due to leave Power Jets. On his last day there, Whittle had to impress an important visitor with his engine.
On June the 30th of 1939, we managed to get a big breakthrough in the attitude of the Air Ministry, in that Pye, Director of Scientific Research, came up to see the engine run, and we managed to keep it going for about 20 minutes in his presence, and he became a complete convert. So much so that he agreed that an engine for flight should be ordered, and that an aeroplane to use it should be ordered too. When I drove him back to the station to catch his train back to London, I had the curious experience of him explain to me all the advantages of the engine, that it could run on any fuel, that it was vibrationless, etc., etc. And I just sat quietly. I was only a squadron leader at this time. I thought, yeah, you're telling me, old boy. This, of course, was the big turning point in the whole job.
The turbojet was saved for Great Britain, but Germany, unaware of Whittle's breakthrough, already had a jet plane.
I was very certain that it would work. But, of course, you always feel there's a danger. And we had made not too many pre-tests. We ran the engine before it flew perhaps several hours at the very most.
The support of a huge aircraft company had enabled Hans von Ohain to overtake Whittle. Heinkel's He-178 was ready just days before war broke out. Test pilot Erich Varsitz was eager to take off.
He started and then he disappeared. And after a while he came back and we thought, oh, he's landing. He didn't. He made another round and we said, oh my God, he must like it. But we didn't have the airplane very filled up with gasoline. He landed and stopped the airplane just where Heinkel stood. And he said everything functioned beautiful and the engine worked well, and he was really himself, very enthused. We had a nice festival.
A jubilant Heinkel rang General Ernst Udet at the German Air Ministry.
I learned later on he called Udet and he said, hey, congratulations, but let me sleep. That's an ungodly time.
By now, Frank Whittle had been forced to move power jets from Rugby to a scruffy foundry at nearby Lutterworth. Ladywood Works was the name of the site. Today, there's nothing to show that history was once made here. But in these buildings, Britain slowly expanded its jet program.
In 1939, we only had just a handful of about half a dozen. And then at the beginning of 1940, we began to build up a team, and I was very careful in picking real quality. You know, first class honours Cambridge, first class honours Oxford, Imperial College of Science. We were advertising. Of course, we couldn't say what we were advertising for. And when we were interviewing them, we couldn't tell them what we wanted them for, though I think some of them guessed from the questions we asked.
Whittle's charm and enthusiasm at once inspired his new team to strive for the impossible. The noise and lack of space at Ladywood forced Whittle himself to work at Brownsover Hall, a country house nearby. Here he worked through the night, desperately aware that his work could shorten the war, and drove himself to nervous exhaustion.
My memory of him really was just somebody always working. And when he was at home, if he took any time off, say Sunday, he would sit in his chair by the fire at Broomfield, and we'd be there with his slide rule, which of course people used in those days to do their calculations, and bits of paper all over the place, working, and a little bit of time for myself and my brother, but not much, not much.
As Britain entered its most critical phase of the war, the expanding team at Ladywood was galvanised by a new order to prepare engines for a prototype jet fighter. Codenamed F-940, we know it as the Gloster Meteor. As a potential war winner, getting it in the sky to fight the Luftwaffe now became the focus of their work at power jets. They did not know that Germany was by now developing its own twin-jet combat planes at Messerschmitt and Heinkel. The country's prototype jet, the He-178, had not been a success, but its last flight was exploited to the full by its maker.
Heinkel invited the Air Ministry to come, and the highest who came was Udet, and somehow Heinkel used that possibility to offer a new design of a two-engine fighter aircraft. And actually, he got the contract about 2 months later.
The plane was the He-280. The Nazis wanted it in 14 months. Heinkel passed this demanding deadline to von Ohain to build its jet engines.
Well, Heinkel wanted things very fast. He was very optimistic, very positive, but a little bit unreal and unrealistic in his time schedules.
In Britain, the Air Ministry still wouldn't fund Frank Whittle properly, forcing power jets to work in impossible conditions.
In addition to our continuing financial problems, we had many others, like having to use the same parts over and over again when they ought to have been scrapped. And of course that was linked with the finance, because we couldn't afford new parts. We had to make do and furbish up damaged parts.
Some people continued to claim Whittle's jet wouldn't even fly. By May 1941, his engine was ready to go in Britain's first jet plane, the experimental Gloster E-28-39. For its maiden flight, the top-secret aircraft was taken to Cranwell, where the jet story had begun. The Power Jets team followed, full of hope. On the same day, a young naval pilot, Eric Brown, was forced to land at Cranwell. Today, he's one of the few surviving witnesses of this historic occasion.
When I landed, I was a bit astonished to find so many civilians present. And when I went to check in at the mess and asked what was going on, there seemed to be almost an air of conspiracy about the whole place. And nobody would give a straight answer to this.
We'd been out the day before for some taxiing trials, and then on the May the 15th, the weather looked as though it wasn't going to work out. So I went back to Lutterworth.
That morning I went to the control tower to check if the weather was good enough for my en route flight to Croydon, but it obviously wasn't. And they said, would I mind doing a weather check for them? Anyway, I landed, and they said, would I be prepared to do a further weather test in the afternoon?
And then we got a message to say that the weather was clearing, so I rushed back to Cranwell again. And in the evening, Jerry Sayre did the flight.
An airplane was rolled out with a shape well, not so much the shape, but the construction of which I'd never seen before, because it had no propeller. And an extraordinary whining noise came from it, and it taxied out to the end of the runway, and after a while eventually took off. And I was quite astonished to know what it was, because I'd never heard at this stage in my career.
W.E.P. Johnson slapped me on the back. He said, "Frank, it flies." And in the tension of the moment, I rather rudely said, that was bloody well what it was designed to do, isn't it?
And it landed successfully, and immediately it landed, it was absolutely inundated with people rushing out and congratulating the pilot. So I realized something quite extraordinary had taken place.
People in the area hadn't heard that particular kind of noise before, and you couldn't really hide it, however secret it was supposed to be. One officer was said to have asked another one, "How does that thing work, John?" And John replied, "Oh, it's easy, old boy, it just sucks itself along like a hoover." Another story was that someone who claimed to have been an eyewitness said there was a Merlin engine inside the hollow fuselage with a little propeller. And he'd seen it. He was a reliable witness, he claimed.
Well, everybody gravitated towards the officers' mess. And so I followed on, and there was quite a lot of hilarity going on in a corner of the room. I asked what it was all about, but still nobody would reveal what was involved. But it was quite obvious. It was something quite momentous.
The flight vindicated Whittle. Britain's new jet plane was better than anybody had realised. One event particularly brought the point home.
The ministry gave us permission to open up to 17,000 just for one flight. And at that engine speed, it did 375 or 380. Anyway, it was faster than the Spitfire.
The news reached London and Winston Churchill. He ordered 1,000 Whittles. Alas, the E-28 could not be a warplane, hence the disappointment felt behind the scenes up at Cranwell.
I would have preferred it to have been the Meteor, which was then on the stocks, because that was a combat aeroplane, whereas the E-28 was just an experimental aeroplane.
Whittle's jet served notice on all piston engines, a notice that fast reached their manufacturers. They now demanded their share of a product none had invented, and which they'd rejected for years. Because of the war, Whittle would have to share his secrets with them.
All this, of course, was putting power jets into a weaker and weaker position from the commercial point of view, and that we had to swallow because it was a wartime situation. And I and several other of my team were serving officers, and we had to put national considerations before commercial considerations. That was very dominant in my mind.
Whittle played a selfless, patriotic role in which he offered his knowledge freely to the British aviation companies. However, they were working flat out to build engines for planes like the Hurricane and the Spitfire. So in 1941, Great Britain turned to the United States, then at peace, for backup in manufacturing its jet engine. The Americans had only been told about Whittle's power plant earlier that year. Ironically, their top scientists had dismissed the concept in 1940. They concluded the gas turbine engine could hardly be considered a feasible application to airplanes. The British government expected to keep the rights in Whittle's invention and did not intend to give it away to a future competitor. But that's inevitably what happened.
We shipped over the engine in parts in the Bombay Liberator, also with the team, who were horribly frightened lest the pilot should pull the wrong lever and they'd all drop into the Atlantic.
The company selected to build the engine was General Electric.
For America, the jet story began the night of October 4th, 1941, with the arrival of a highly secret engine assembly at a Boston airport. It was Britain's now famous Whittle turbojet, the first jet engine successfully produced and flown by the Allies.
Gentlemen, I give you the Whittle engine. Consult all you wish and arrive at any decision you please, just as long as you accept a contract to build 15 of them.
General Electric had that engine, their engine, version of the W2B, called the Type I, on test in April of 42, so just rather less than 6 months, which is astonishing. And even better than that, 6 months later, the Bell Aircraft Company had their twin-engine jet flying. It was agreed that I would go over and help them out. And so I went over at the end of May. I went to Lynn under an assumed name. They insisted I use an assumed name. I called myself Whiteley. There were times when I forgot it, like in the hotel I would waking up, sign for my early morning coffee, and forget that I was supposed to be using an assumed name, and of course sign the real one. I'm told that that didn't matter really because the waiter was an FBI man.
In the Great Republic, Whittle was treated royally, and he in turn was astounded by what he found there.
It was most satisfying to see the work GE were doing because, well, they got on with the job so fast. It was remarkable, and their enthusiasm was most inspiring. And I thought at the time, if only I'd had that kind of cooperation a few years earlier, what a difference it would have made.
In America, doctors found that Whittle was by now battling with severe ill health. Back in Britain, the problems that caused it had only got worse.
The engine that was destined to be the power plant of the Meteor was a more powerful version of the experimental engine, really. There was no major difference. It looked quite similar from the outside.
The Royal Air Force eagerly awaited the Meteor, but Power Jets was not allowed to produce the engines for it. That job had been contracted to a car maker, Rover.
Glosters were getting on with the job fairly well, but Rovers were making an absolute nonsense of the engine. They just hadn't got the people who could do the job, and they thought they knew what to do. The situation became so bad that it looked as though there would be a complete hash of everything. The Rover were making such a poor job of the engine that the order for the production of the Meteor was cut right back.
Rover tried to redesign its engines and held up the Meteor by 2 years, but there was also dirty work.
We intended that the Rover company should be subcontractors and only subcontractors, but unfortunately they went behind our back to the ministry and tried to get direct contracts, and eventually they succeeded in doing that. And instead of being subcontractors to us, they in effect became competitors who had the advantage of having all our information handed to them on the orders of the ministry.
In December 1942, A solution was at last found to the problems with Rover. Rolls-Royce took over the job of building Whittle's engines. But the mighty company would only weaken Power Jets further.
Ernest Hayes was the chief executive of Rolls-Royce. He was responsible for the Rolls-Royce part in taking over the jet development. Of course, he had come to realise that this was the future of the aero engine. And since Rolls-Royce then were one of the most prominent aero engine firms in the world, he wasn't going to be left out. I would call him an honest rogue, because when he was going to do the dirt, he told you he was in advance. And one of the things he said to me on one occasion was, he said, "We're going to be the centre of this job, and nothing you can do will stop us." By 1943, the Rolls-Royce having made such a big difference to the prospects of the engine, the ministry agreed to reinstate the production of the Meteor.
With Whittle's engines, the plane finally made its first flight that year. Yet it should have been ready 2 years earlier. And had the Air Ministry pursued Whittle's idea back in 1929, a similar plane would have been available by the start of the war to repel the Luftwaffe. Lives would have been saved. The war even shortened. At least the work of Frank Whittle could now have a bearing on how that war was fought.
I thought that he was doing something quite important, because every time I asked my mother what he was doing, she used to say, "Oh, well, Daddy's doing something very hush-hush." I didn't become aware that he was anybody out of the ordinary until 1944 in January, when they made the whole thing public. And then the house became surrounded by reporters.
We had been working in complete secrecy until early January 1944, at which time, for reasons I don't really know, the British and American governments decided to make an announcement about it. It was like the world blew up around me. The shock was very considerable.
Whittle and his engine dominated the front pages.
Says here in the Daily Herald, "I knew Frank had a secret," says his wife. So the cat is out of the bag. How strange it seems to be able to talk about it. It may mean that I shall be known throughout the world. In any case, my younger son Ian is a far brighter boy than I was at his age. I think he will be a success, the success of the family.
Had you seen that before?
No, I've never seen that before. Oh dear, how wrong.
As industry reaped the rewards of Whittle's genius, new jet fighters joined the Meteor. First off the drawing board was de Havilland's brilliant Vampire. The pilots loved their new equipment, although the planes remained highly secret, as Eric Brown discovered when he came to fly them.
When I was allotted to the jet flight at Farnborough, of course it was a top secret flight, and it was in a hangar at the far side of the airfield, well away from the main activity, and there were RAF regiment guards there with guard dogs, so it was very highly guarded at the time.
Once inside, the plane was a revelation to Brown.
We're getting into the cockpit of a jet airplane for the first time. You are struck by the wonderful view, because in a tricycle undercarriage, no propeller or large engine ahead of you, it is quite remarkable. And once you start up the engine, although to listen to a jet, if you're outside the cockpit, it sounds thunderous. When you're in the cockpit, it is incredibly quiet.
Frank Whittle often visited Farnborough to check how his invention was performing.
It was quite obvious he was itching to get his hands on it and fly it. But we were always alerted that he was coming, and a little memo would be passed round saying, would you make sure that the 2839 was not serviceable for flight on that particular day. And because this would stave off Frank, it was obvious they didn't want this wonderful airplane and this wonderful man to be united in case there was an accident. So he twigged this pretty soon, and I think he played along with it.
In July 1944, the Gloster Meteor became the first jet fighter to enter operational service. when the Air Force allocated its initial supply of planes to 616 Squadron at Manston in Kent. By now, the Luftwaffe could no longer mount air raids over Britain, but these Meteors were quickly put to work, intercepting a lethal new menace, the V.1 guided missile. Germany's flying bomb terrified the Londoners who were its target. In the skies over Kent, the Meteor pilots sought to prevent V-1s reaching the capital. Some used their wingtips to flip the missile over, so it crashed. Around this time, Allied pilots were startled to find themselves being attacked by a German plane with no propeller. This was the Messerschmitt 262. Germany's own jet program had by now advanced to this sophisticated design. It had been chosen instead of the HE-280. The Nazis never liked Heinkel and had cancelled his promising jet fighter. Yet it could have been mass-produced by 1944. By contrast, the 262 arrived late and was rushed into battle too soon. In Britain, meanwhile, Frank Whittle seemed at his peak. He was a national hero, while his company now had a custom-built factory from which to expand. He had a clear vision for its future.
I always wanted to include manufacturing in our duties. In 1944, Power Jets had reached the point where they were able to produce, say, batches of 40 or 50 engines. And we had a first-class nucleus for proper manufacturing organisation.
Power Jets also had some outstanding work in progress. Whittle was already planning the second generation of jet engines.
There was the LR1 turbofan, which would have been the first turbofan in the world. There was the engine for the Miles M.52, the supersonic aeroplane. Those were our two big projects which we had in hand.
LR1 stood for Long Range 1. Whittle saw the scope for jets that would fly planes further as well as faster than pistons. But he would need a more efficient engine.
From the earliest days of the turbojet engine, I was bothered by the fact that it has a basically low propulsive efficiency, about 50% as compared with, say, a propeller at moderate speeds of 80%. And so the answer to me was that we must gear down the jet in some way. And that led to the concept of the turbofan, for which I took out a patent in 1936.
The turbofan is a turbojet to which a fan has been added. This fan causes air both to flow through the core of the engine and to bypass it. This additional jet of cold air increases thrust and improves fuel economy. The design had huge potential.
With a turbofan, you can expect propulsive efficiencies of 75% or even better if you have a very large bypass ratio.
As piston engine bombers approached their design limits with planes like the Lancaster, Whittle saw a timely use for his new bypass jet.
As the war progressed, in 1943, for example, I came to the conclusion that it could be the answer to a long-range bomber for the Pacific War. We also visualized it as an engine for a transatlantic aeroplane.
Whittle was already predicting long-range jet airliners and the kind of engines they would need. But it was the other Power Jets project that would grab people's attention.
The engine for the supersonic plane, the M.52, was an aft fan with afterburning, all tacked onto the back end of a W2700 jet engine, and that should have given sufficient power for the Miles M.52 to do 1,000 miles an hour. I think it would have done it.
Despite its huge potential, Whitehall never felt comfortable with Power Jets. It was a private company, but its driving force was a serving officer, and it was publicly funded. The fault lines were clear.
I realized that there was a complete mess from the contractual point of view. There were no effective agreements, and no one except Power Jets had risked any money, except the government, of course. And I felt that the government, having put in $2 million, that all the companies should be nationalized, forming a collective turbojet establishment, and of course I hoped that Power Jets would be at the top of the pyramid, with myself as chief engineer.
Whittle's proposal was considered in the high levels of government.
Sir Stafford Cripps, the Minister of Aircraft Production at that time, used what I'd said to get the ministry out of the mess that they created by nationalising power jets only, which relieved them of all their undertakings.
It was expected that Power Jets would still continue with its advanced engine projects.
But then other firms began to create difficulties. They said they weren't going to have the government competing with private enterprise. So considerable pressure was brought to bear on the ministry.
And the minister caved in to the large aero-engine companies.
So we, the people who had pioneered the whole thing, were deprived of the right to design and build engines. Sorry. That was too much for myself and my leading team members, and most of us resigned.
The supersonic plane and the turbofan project had by then been cancelled. The civil servants found a reason to justify this loss.
Believe it or not, the minister said that people wouldn't want to fly at speeds more than about 250 miles an hour.
As Whittle left Power Jets, he was acutely aware of the commercial opportunity that was now at stake.
The position in 1945 and 1950 was that Britain was really ahead of the world in all forms of gas turbine development, but stupidly we allowed the lead to slip away.
In 1945, the Allies discovered the Germans' impressive range of jet planes and their designers.
After the capitulation of Germany, I was at that time in Farnborough the CEO of the captured enemy aircraft flight. So I was sent to Germany and to look at their advanced aircraft, and also at the same time to interrogate their designers and test pilots. Amongst them was von Ohain, and naturally I wanted to know what his connection with the Whittle patent had been in Germany. But he was not going to answer this question. He was very non-committal and sidestepped it as much as he could.
Brown flew the various German jet planes, including the Messerschmitt 262. The Allies already knew that its engine, the Umo 004, was a sophisticated axial flow design. Now they could compare its performance with that of the less complex British jets.
So a more efficient engine in many ways. It was highly unreliable. The Umo 004 in operational service had a scrap life of only 25 hours. And the engine, when I flew this engine, I found it extremely sensitive and difficult to handle because it did not like quick throttle movements, either accelerating or decelerating. Any quick throttle movement, either way, could possibly cause a flame out of the engine.
Whittle's jets were more reliable, but he could take them no further. The course of events brought anguish.
I think my mother was most distressed by what was happening to father. She was most distressed. I could remember her crying about it at times, because she would tell me, "Oh, Daddy's so unwell because of what's happening, and it is such a shame, and how can they treat him like this?" Yes, it's very sad for her. He managed to soldier on in the RAF, and he was an Air Commodore in 1946, but in the end, by 1948, he'd been declared as unfit for flying, and somehow that was the last straw, and he and the RAF both agreed that he should retire, and he did.
It must be very sad for him.
Oh, very sad, yes. The Air Force was everything to him.
The public knew none of this and saw a war hero receiving his just rewards. In 1948, Whittle went to Buckingham Palace to collect a knighthood. He also had a financial award for his invention, which was good for the time. Worth nearly £3 million today, it would soon become clear he was greatly under-rewarded. He sought a role, but his stature made him hard to place in an industry he himself had founded. No engine maker hired his services.
In many ways, I paid quite heavily for the work I did. There was the awful race against time. That dominated life. On top of all the technical difficulties, there were the financial difficulties, there was the skullduggery of people who were messing things up, and it was frustration after frustration, and it took its toll. I began to have a series of nervous breakdowns, and for years, it was years before I really recovered my health.
Britain stole a march on the rest of the world when it launched the first jet airliner. The beautiful new plane, with its 4 engines, was a fruition of all Frank Whittle's early visions.
First, after he left the RAF, he turned his mind to the introduction of the Comet, and he joined BOAC as a consultant to help them introduce the Comet into service. He was very worried at the time that the thing was being rushed into service. I've got his 1949 diary where he discusses the strength of the square windows, and he was worried about that at the time, and was making a suggestion to de Havilland's on how they could get over the problem.
Whittle's advice was ignored. The Comet crashes which followed were caused in part by its square windows. With time on his hands, Whittle travelled and tried to recover his health. He also turned to writing his memoirs. The jet age took off without Frank Whittle, but the Royal Air Force was soon re-equipped with the benefits of his invention. By 1950, the Gloster Meteor provided the backbone of Britain's air defence capability. It was a fitting outcome to all the secret toil of the Power Jet's team in the dark days of the war. The nation did at last build its own supersonic fighter, in the shape of the English Electric Lightning, while jet engines also powered an awesome British fleet of nuclear bombers. But the country could never really afford such planes. They would later play an important role in the Falklands campaign, but were destined to become museum pieces. British civil jet planes fared little better. After the Comet crashes, it was Boeing 707 which brought long-range jet travel to the masses. By 1960, airlines were mostly buying their planes from America. That year, the bypass engine entered service. Turbofans soon followed. With their far better fuel economy, they were just what the airlines needed to realize low-cost global travel. For Frank Whittle, it was the ultimate vindication of his wartime vision, and revealed the sheer folly of cancelling his pioneer turbofan. Yet he never worked on jet engines again, and memories began to fade of how the story had begun.
I think in this country they were beginning to forget all about Frank Whittle by the 60s and 70s.
It was all so different in the United States.
They were so much more gung-ho. They were very good at slapping him on the back and telling him what a good chap he was.
In 1976, Whittle went to live in America.
I think he felt more recognised over in the States than he did over here.
After the war, Hans von Ohain had himself moved to America to work on jet propulsion for the US Air Force. Fascinated by each other's work, Whittle and von Ohain became good friends. Back across the Atlantic, Britain eventually rediscovered its genius of the jet.
By 1986, even the Queen took a hand and awarded him the Order of Merit. And other honours came along following that. So I would say from about the early 80s onwards, people began to remember who it was who was the prime pioneer of the turbojet.
And also a man with a profound legacy. Today, we make almost 1.5 billion air passenger journeys a year, cheaply and safely, thanks to Frank Whittle. He shrank the world, but his gift to Britain is less appreciated. Its famous plane makers have departed, but today, Rolls-Royce is a world leader in building jet engines.
I'm often asked how I feel about it, and it's a question I find very difficult to answer. things could have been a lot better. We could have had a much bigger influence in the war than happened. But when I see what's happened in the way of civil aviation and military aviation too, but particularly civil aviation, I can only say it's extremely satisfying, especially when you see something like the Concorde. And one of the things, you see, I never foresaw when I was working on this thing, is that I would be a passenger crossing the Atlantic in 3.5 hours. And incidentally, another thing I didn't foresee is that I would have a son who would be flying 747s as a captain in Cathay Pacific.
Kai Tak Aerodrome at Hong Kong had a very interesting approach, a curved right-hand turn right down to almost a touchdown. And when Father came with me in the back of in the cockpit in a Boeing 747, he was very startled when he saw that his son was flying an airplane at 1,000 feet straight towards the foothills and then making a steep final turn, which of course was quite normal at Kai Tak. It was the way you had to do it. I hadn't briefed him, unfortunately, so he was very white-knuckled by the time we landed. He was continuing to theorize in aerodynamic improvements and aero-engine improvements until the end of his life. He always took an active interest in Concorde and looking into a second-generation SST, supersonic transport, and making recommendations and speaking publicly and privately amongst the industry to try and encourage the airframe manufacturers to take the risk and embark on another generation of supersonic transports.
Concorde is a marvellous aeroplane. I've flown it many times, but I'm looking forward to the next generation of supersonic transports, which I think should be capable of carrying 300 passengers for distances of the order of 4,500 miles, like San Francisco, Tokyo, at speeds of about, a Mach number of about 2.3, that's getting up to 2,000 miles an hour, as compared with the Concorde's 1350. But beyond that, I think we're going to see even much higher speeds than that in due course. Unfortunately, they're going to be very expensive propositions.
Sir Frank Whittle died in August 1996, assured of his position as the greatest aero-engineer of the 20th century. The Royal Air Force paid fitting tribute to its distinguished son with a memorial service at Westminster Abbey.
He and I had wanted the opportunity to fly together, preferably in an open cockpit biplane, so that together we could loop and spin and climb and dive. This modest ambition was never realized for one reason or another. The nearest we got was when I flew him to Hong Kong in a Boeing 747. On the last morning of his life, I leant over his bed and said, "Dad, let's put on our kit and go flying." He opened his eyes and looked at me and smiled. That evening, with Hazel holding his hand, he died. And I wondered if he went flying, and if he did, if he went on his own, or did he have a companion?
he was cremated in the USA, and the air attaché there brought his ashes over to this country, and I went to Heathrow to meet the aeroplane, and I came home and put the ashes on the bookshelf in my study with the ashes of my mother, who died 3 weeks earlier. I decided to put them in at the church of Cranwell, and they organized a meteor and a vampire. So we flew the ashes up to Cranwell, and they were interred there with a little ceremony.
Welcome to the DroneScapes Aviation channel. Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.